Hi, good morning. Hope you are enjoying all the videos on engineering drawing so far uploaded. And here again, I come to you directly to give a clear concept of line inclined to both the planes. When a line inclined to both the planes, there will be we have to understand the concepts very clearly. Why? Because when a line is inclined to one plane, we don't see the true length of the line in the front view or in the top view. So when a line is, when you want to see the true length of the line must be parallel to a plane. Okay? So when a line is parallel to a plane, the projection onto that plane will be true length. When a line is inclined to one plane, the projection onto that plane will be less than that. So here we are going to see a line AB. Say here it is given. AB is the line and 100 mm long, right? That is the true length of the line. Point A is 20 mm above HP and 30 mm in front of VP. And the line is inclined at 30 degrees to HP. We call this angle as theta, and 45 degrees to VP, that we call it as phi. Now we want to see how the final projections of this line when it is inclined to both the planes, both HP as well as VP. Right. To start with, we have taken a line, the XY, right, and the reference line. I am taking the plane here. I am assuming, say this as a line of 100 mm long. Okay. Now I have taken the vertical plane here, the vertical and horizontal planes, reference planes, and this is the horizontal plane and vertical plane. The line is in the first quadrant. Point A is 20 mm above HP, here 30 mm in front of VP. This is the point A to start with. So we'll mark the point A first. Point A is 20 mm above HP, A dash, this is 20 mm, and 30 mm in front of VP, top view, that is 30 mm. Now, say I'll just erase this. We have taken the planes like this. Okay, the line is initially the line is, say, true length is 100 mm. I am taking the point A position 20 mm above HP, 30 mm in front of VP. And from here, I take the line in the first initial position. I call it as first initial position because actually when the line is making angle with both the planes, final position of the line should be like this. But here, to get this, I start with an initial position of the line. I call it as first initial position. Okay. The entire line is taken 30 mm in front of VP. And the point A is 20 mm above HP. So here, this is the line, entire line is parallel to VP and inclined at 30 degrees angle to HP. Okay, that is angle theta, we call it as true inclination with the HP. We draw the position of this line when in the front view, we see a line at 30 degrees angle and true length 100 mm is visible. I call this point as B1 dash. It is not a B, final position of the line. So here, final position of this line is, this is the B. Because this is the initial position, I consider this as B1. So AB1 dash is the first initial position and here is the true length. when you see this line in the top view, we see this line parallel to the projection on the horizontal plane is parallel to the reference line and in front of it, 30 mm in front of it. So here it is, draw projectors, 30 mm, right? I call this as B1. Here we have to make two observations. One is, when the line is inclined at 30 degrees angle to HP, the projection onto the top view will be less than its true length. It won't be 100 mm. Okay. Now, how much is it? Depends on the angle. Okay. So when the line is making 30 degrees angle, we get the length of the line in the top view, and that is equal to AB1. AB1 is the length of the line in the top view. Coming to the second observation, when the line is making 30 degrees angle with HP, the point B is at some height above HP, and this height is fixed until this angle with HP is constant. When this line angle with HP is constant, the point B is at this height. Whatever may be the position, the line may be like this or like this. When the angle is 30 degrees, this height is fixed. That means, suppose I am moving the point B1 like this, at the same angle, keeping here angle with the HP constant. Suppose if I am moving the line, what happens? The point B1, B is at a fixed height above the horizontal plane. That's why I draw a line here and I call it as the locus of B in the front view. The point B will be always at that height above the horizontal plane. That is one thing. So these two are the observations. One is the length of the line in the top view is AB1. In the front view, this is the locus of, we call it as the locus of B. Locus of B in the front view. Okay. Now, we'll take the line in the another position, that is line second initial position. I call it as second initial position. The line is parallel to HP, making 45 degrees angle with VP. Hope I made it clear, right? Is it visible? This is making 45 degrees angle with the VP and parallel to HP. The line, entire line is 20 mm above HP. Point A is 20 mm above HP. So entire line is 20 mm above HP. So in this position we draw the projections. How? Let's draw it here. Suppose I start with A here, okay? Or if you want, you can draw it separately, or we can I'll draw it here itself. Okay, point A at 45 degrees angle to this, and this is the true length of the line because it is parallel to HP. This is the true length of the line, and I call this as second initial position, and that I call this as B2. Okay. Now, this is B2. Here we draw the front view of this line. The front view of this line, when it is making angle with VP, right? In the front view, its length appears to be less than its true length. How much? It depends on the angle with VP. So in the front view, we see the less than its true length. So in the front view, here the front view is parallel to the reference line and it is at the height of A. So this is B2 dash front view. So it is B2 dash in the front view. Now here again we make two observations. What are they? One is the line is parallel to HP. That means when the line is parallel to HP, in the top view we see the true length. In the front view we see the less than its true length. Coming to the observations, when this angle with VP is constant, the point A, okay, A is fixed, angle is fixed. So the length of the line in the front view is A dash B2 dash. A dash B2 dash is the length of the line in the front view. Now that is visible here, A dash B2 dash. Second observation is, suppose this is the final position of the line. We know that because the line has to make angle with the HP as well as VP. So when the line is moving like this, how the angle with VP must be constant, and it is actually making 0 angle with the HP now, but it has to make 30 degrees angle with the HP. So keeping this angle constant, okay, it is the point B is at some distance in front of VP. Now we move this point B upwards. The point B is moving upwards like this. So what is happening? The point B is at a fixed distance from A, at this distance, and is moving here like this. How? It is moving as if it is an arc of a circle in the front view. It is moving as if it is an arc of a circle in the front view. How far? Earlier already we have seen that in the first initial position we know the point of B. That is, we drawn the locus of the line point B here in the front view. When this line moves upwards and reaches this particular height, it attains an angle of 30 degrees. So in this position, in the second initial position, we are moving this point B upwards until it reaches the point B locus in the front view. So in the front view, the point B is moving as if it is an arc of a circle, and in the top view, this point B is moving at a fixed distance from the reference line. That is, the point B is moving at a fixed angle, so this point B is at a fixed distance from the reference line. This line is called the locus of B in the top view. Locus of B in the top view. Now, we made all the 4 observations. What are they? This is the length of the line in the front view, and this is the locus of B in the top view. This is the locus of point B in the front view, and this is the A, B1 is the length of the line in the top view. Keeping them, now I will erase this. I draw freshly here. The point A is at this distance, that is A dash. A here. Now, the front view, right? AB2, I take AB2 here. I take AB2, second initial position, and rotate this point B upwards. That is, in the front view, B2 dash is moving upwards like this. How far? As if it is an arc of a circle. So I think it's better you can draw it here itself in the same position, so that it will be clear. No need to confusion. So A dash B2 dash as radius. I am rotating the point B upwards. How far? Until it reaches the locus of B in the front view. When it reaches the point at this height, what happens? The length of the line, the angle will be 30 degrees with the HP. Okay? And because the length of the line in the front view is this, the angle with VP is constant. Angle with VP is constant. So the point is, this is the final position of B. That is B dash. Final position of B. Join A dash B dash. That will be the final projection in the front view. So here it is. We call it as angle alpha. Apparent angle. Here the line is actually making 30 degrees angle with the HP, but it is appearing to be making more angle. Clear? to understand this, I just show you one thing here. Suppose this line is making 30 degrees angle with HP. Okay. So when you are moving upwards, the angle with the HP is constant. The height of the point B has reached a certain level. Then what happens? This angle 30 degrees will be attained. Okay. Or else, suppose I show you one more example. Suppose this line is making 30 degrees angle with HP. Okay. The point B is at certain height. Suppose 70 mm above HP, above this plane. Now, I keep the angle same constant. How do you draw this? In the front view, you draw a line at 30 degrees angle. Like this. This is the front view of this line. 30 degrees angle. Suppose I keep the angle same 30 degrees constant with the HP. This is making 30 degrees. How is this line now? If you draw the projections of this line, I get the point A here and B here. If you join them, this line appears to be like this. When you see this in the front view, it appears to be making 90 degrees angle. Is it really making 90 degrees? No. Because we know that this is making 30 degrees angle only. So what is happening here? When the line is making parallel to VP, then only we see the true length of the line and true inclination. The true inclination is not visible when it is making angle with the HP and VP. So, in this position, final position, when the line is making angle with both HP and VP, we are not getting the true inclination in the front view. That's why apparent, it appears. That's why we call this angle alpha as apparent angle. Okay. Now, to draw the final position of B, we know that the point B is at this distance in front of VP. Okay. And also we know that the final position of B in the front view. We can just draw a projector joining up to this projector locus and we get the point B here. Otherwise, we can have a test whether we have drawn it correct or not. We make a test here. How? Let's go to the first initial position. Let's take the first initial position here like this. We know that the locus of B in the front view and we know the length of the line in the top view. How much is it? AB1. AB1 is the length of the line in the top view and the locus of B in the front view is this one. The locus of B, point B is at this height only. Now, I do one thing. I rotate this line because the line is not parallel to VP. It is making angle with the VP also. So, keeping this height constant, I rotate the line like this. When you rotate the line like this, in the top view, because you are keeping the length constant, the point AB1 constant, A as center, AB1 as radius, the point B1 moves as if it is an arc of a circle and is moving away from the VP. Like how far? Until it reaches the locus of B in the top view. So, in the top view, the point B rotates, A as center, AB1 as radius, B1 is rotated as if it is an arc of a circle until it reaches the locus. This is the final position of B. In the front view, the point B1 initially here moves towards left side. When it is rotating like this, in the front view, the point B moves towards left side. That's how, and here is the check whether we have drawn correct or not. Draw a projector from B here. It must, the projector must pass through this point and join AB. Join AB here. What is this? AB is the final projection of the point line in the top view. So A dash B dash is the final projection of the line in the front view. AB is the final projection in the top view, and this angle here is apparent angle. It is actual inclination of the line. We know that it is making 45 degrees angle only with VP, but it appears to be making more inclination with VP. So we call this as apparent angle and is named as beta. Alpha and beta are the apparent angles. Alpha in the front view, beta in the top view. This angle 30 is generally, in terms of notation, we call it as theta, and we call this one as phi. So finally we have drawn the projections of the line A dash, B dash and AB. Okay. So like this, you have to, out of all this, when you observe this problem, we get some parameters. What are they? We are given the true length of the line AB, that is 100 mm, and we are given the theta, angle with HP 30 degrees, angle with VP 45 degrees. We find out alpha, beta, and also we find A dash, B dash, final front view, A, B, final top view. How many parameters? 7 parameters are there. 7 parameters are there here. It is something like a mathematical problem. You can just imagine this as a mathematical problem. In a mathematical problem, you will be given some parameters and you will be asked to find the remaining parameters. The same thing happens here also. How? You will be given some parameters. Maybe you are given this set and asked to find this. Okay? Or you may be given 1, 2, 3, some parameters. So out of all 7, you will be given some parameters and you will be asked to find the remaining parameters. Hope you understood this concept on line inclined to both the planes. This concept is very much useful and we will be using many a times, and many a times we will be using this concept. So hope you understood this, and hope you are following all the lectures which I have been uploading. And if you like this video, please do like and also subscribe. That will be motivating to me to do further more videos. Thank you very much.